Is that close?
Yeah.
Yeah?
Fergus is there.
Enjoy the Scottishness. Thanks. Welcome, Dale.
Cheers. Hey, I'm here to talk about the offline web. And to this day, I still get a lot of blank stares when I say I'm going to talk about the offline web. People are like, that doesn't even make sense. Like, the web is the web. It's clouds and transferring information from server to server. What does the offline web even mean? What does it mean to work offline? And so, like, the web means a lot of different things for a lot of different people. A lot of people love HTML, CSS, and JavaScript, and for them, that is the web. For a lot of people, it's Tim Berners-Lee's original vision of hypermedia and hyperlinks and being able to transfer documents from one computer to another. The thing that excites me the most about the web is it is quickly becoming our most ubiquitous computing platform. Especially with the rise of Node.js, like web technologies like JavaScript, you can build the type of web technologies, build the type of applications like email applications, IRC clients, all of the things that were traditionally written in kind of native platforms. You can start writing these in web technology. And this is only just starting to become a real vision. Like, it's something people have wanted to do for a long time, but it's only just started to become real. And working offline is a big part of that. And so why offline? And why should you care about offline? Why should you go home and build your websites so they work in offline? Because that's what I want people to do. I want people to go home and be excited about building offline websites. The first reason is obvious. It's just because people are offline. A lot of people traveled here from various places. They don't have data roaming. When you travel back and forth from work and you're on the underground, there are just a lot of situations where you might not have a connection to the internet. And when you don't, I don't want to pick on web rebels too much. Oh, crap. I actually connected to the internet there. But I mean, this is the experience you get when you already seen that page load, but when I go to it again, you get to play a little game here, which a few people might not know. But I mean, in terms of useful user experiences, I would like to be able to see the schedule. I'd like to see the speakers, even when I don't currently have an internet connection. So, I mean, that isn't providing the best user experience. And it's quite easy to kind of dismiss this as being a bit of a it's like niche. It's like David DHH wrote an article quite a few years ago saying you're not on a fucking plane. Between the people in this room, there might not be a lot of time where you're actually offline, and when you aren't, you can read a book. But really, like, we are the niche in this community. We are all mostly, I am assuming, tech workers. Ourselves, our employers pay a lot of money to make sure that we have fast and stable internet connections. We probably mostly have unlimited data. We probably even pay for roaming sometimes or buy SIM cards when we land because it's important to us. And so I think there's a lot of like user empathy involved in here. Even the 40% of the world that do have access to the internet right now, they don't exactly run around with unlimited 4G data connections. And so it's worth thinking about the people that aren't yourselves, that don't have a tech job, that don't rely on the internet every day, and providing a good user experience for those people. But as I said, it's not only about being offline. There was a talk this morning about making how much latency affects performance, and it's very true. There was a famous time when Facebook changed their mobile client, and it used to be an UI web wrapper, and they changed it to native, and they're like, look how much faster it is now. And it was fairly obvious, like the first time you loaded it up, to see why it was so much faster. I don't know how much you can see of this, but they tried to load 2 to 4 megabytes over the network for every link that you clicked on. This made 206 requests to load a single page. I'm actually amazed that it did load in 6.2 seconds. And that is on a desktop with a really fast Wi-Fi connection, when you're taking into account like mobile latency, this was always going to be really slow. And so when you compare websites built like this to the native application, you're comparing apples to oranges. There are ways to build web applications that don't load 4 megabytes of data on every page load and kind of hope that the browser cache will figure it all out and make it a bit faster. And so, like, I can almost guarantee a lot of people here will be working on minimizing their JavaScript and CSS, making sure their assets are as small as possible. A lot of people will even be using CDNs and making sure that their requests come as quickly as possible. But I can almost guarantee you will do nothing to make your website faster than to make it offline capable and to make sure that it only hits the network when it actually absolutely has to. And yeah, people notice this. I'm surprised that anybody noticed when we put an app cache on PouchDB.com. People are like, this is the fastest thing I've ever, like, website I've seen. And, like, compared to the experience of I'm still offline, and these just run really fast. Like, this has the entire documentation of PouchDB. I mean, you visited the website once, and now it's available for you, and it works really fast. All right. And so another kind of an almost side effect of being offline capable is you're suddenly more failure tolerant. People talk about decoupling models, like people build web applications. On the client side, they'll talk about decoupling models and views and controllers and such, but they don't talk about decoupling like this computer that's sitting here rendering the application for the user from the server that's sitting thousands of miles away doing the processing for each of those requests. So it's just a nice fault-tolerant system. If you build an offline-capable web application, then it means if your server goes down under load, there's a good chance the user might not even ever notice. And there are some more tangential benefits, and these are a little less widely applicable, but obviously offline architectures generally try to do more on the client, which means you're not sending as much data backwards and forwards, and obviously that's beneficial for security and privacy. There's also peer-to-peer-like applications. One of the things we're working on Firefox OS is to switch applications just by tapping your phones together, and you can send an application to that other phone. And obviously, these type of things only work if you've got offline capable and peer-to-peer type technology. Sweet. So you're all sold? We're all going to go home and build offline web applications? Yeah, Brian is. So how does it all work? Like, how do you even make these websites that work offline? And I've kind of made an order of like arbitrary definitions of how easy it is. So we start with a static site, which is the easiest type of thing to go offline. And that is exactly what I had with PouchDB. That is just something that is built with Jekyll, or you might even be hand editing the HTML. And all you need to do is put it on a file server, and that is a website that is up and running. It doesn't need a PHP or Rails or Node.js or whatever. And so the first thing you're going to do with this when you try to make that work offline is appcache. You've probably, as a few people laughing, have heard of the article. It was Lanyard made their mobile site work offline, and they come out with a really popular article, Appcache is a douchebag. And it kind of listed all of the problems that they had working with appcache, because it's conceptually simple, but it's fairly annoying to work with. And I'll mention a few of the annoyances. But, I mean, I feel like douchebag is hard. I feel like mostly just a pain in the ass. And so this is what appcache looks like. This is an appcache.manifest file. And conceptually, it's super simple. There is a list of files, and when the browser sees your appcache, it will take those files, it will store it locally, and next time it tries to serve those files, if they're in the cache, it will serve them from the cache. And that is all that is needed to make that PouchDB website ridiculously fast, because it's no longer, even if you rely on browser caching, it's no longer checking e-tags and making requests. it is serving directly from the file system, and you can't really get any faster than that. It's definitely going to be faster than loading over the network. There's a few other things like network and fallback, but they're fairly easy to understand. If you start using it, you can go into the details. So cache and validation. The first thing that people run into when they start using appcache is you sit there, you change your code, you refresh the page, and you're like, what the hell? It's still the same page. This isn't how web development works for me. And that is, I mean, it's kind of funny. This is why people would say appcache is douchebag. It's actually doing its job. And it's worth thinking about why it works that way, why you need to make 2 refreshes every time you update your app cache, unless you disable it. And that is because, like, a lot of people might think, oh, when I go offline, then it will serve it from the cache, but when I'm online, why not just serve me the newest page? And it's because being online is a really hard thing to define. Like, one request might work, the other might break. One host might be broken, the other one might be working. And a request could take like anywhere from milliseconds to minutes to respond at all. And so it's impossible to really say I am online, because it could take minutes for like your second or third request to actually respond. And so appcache made the decision to say, you may possibly be serving invalid data, stale data, like there may be an update waiting for you, but we're going to serve from the cache, so it's going to be show up on your computer immediately. You're going to get a really fast load, and then we're going to update the cache in the background when we see updates. And so on the next refresh, when the cache is updated, then you see the new content. And when you're building offline-capable web applications, like these are the type of trade-offs that you need to think about and make for yourself. Like there might be some situations where you're like, no, this needs to be absolutely up-to-date all the time, in which case you won't show from an invalid cache. You'll just show a waiting thing saying, I'm waiting for the most up-to-date data. In general, this is usually a good trade-off to make. The other problem people have with appcache is its caches all the way down. It's not just a new way of caching, it's an additional way of caching. So the biggest mistake you can make is to cache that manifest file, because you need to update that manifest file to be able to make any changes to your website. And if you cache the manifest, you, by definition, can't update it. It will always load from that cache, and your website is completely broken forever. And like, I could have fixed this, but I didn't, just because it would make for a demo. If I go to a website that I made quite a while ago, if you go to this, you'll get the updated, nice new version. This is the only version I will ever get until I clear my cache. And so it's important to think about that, because I can clear my cache and it's nice and easy, but to expect an end user to think about that is almost impossible. You can't have that in your FAQ. You need to make it work. And so it's worth thinking about when you build offline capable web applications, it's not just your own server that's the state. You need to start thinking about the fact that we're storing state in the client as well, and dealing with they might not have updated in months or years. You need to deal with upgrading their data as well. And so static sites, like the app cache is all you need to make a static site work offline. But next up is single-page applications, and these are the things that are becoming a lot more common these days. You might think of like Facebook and mobile and Twitter clients, IRC clouds and such, where you're using React or Angular, and you're basically not storing content in the HTML. You're just sending empty HTML pages, and then it's loading content over the network. And so the app cache that you've already built, that will work perfectly fine. It'll store all the JavaScript and CSS and JS. But then you load up the application, and you can get something like this, which is a step up from the browser 404 page, unless you really like that game. But it's still not particularly useful to an end user. There's nothing for them to interact with. You're not providing a hell of a lot of value apart from a bit of a nicer UI. And so when you need to start fixing this is when you need to start thinking about storing data locally. Dynamic data that is coming from the user and is on a per user basis. It's not just static data. And so browsers have introduced a whole bunch of different APIs for this. The first one that you'll probably come to is local storage. It's a really simple API. It's just a global object on the browser. You just put a key in there. You can do ifs. You can check the value of that key at any time you want. It's a simple API. It gets weird and gets a bit bad. If you try and store objects, it only stores strings ever. That's the only thing local storage will ever try to store. So if you try to store an object, you'll get the stringified version of that object. And it's fairly easy to get around that. You just JSON stringify and JSON parse things when you go in and out of local storage. But because it has that synchronous API, like it needs to block the UI every time it reads data from local storage. And if you're encoding the data or decoding it on the way in and out as well, like if you're storing large amounts of data, that can slow down your UI significantly. It doesn't have indexes or the ability to query. So if you want to do any kind of reasonably large amount of data, you need to either come up with fancy schemas or be able to store everything in memory. And even if you did, the storage it varies very much between browser to browser, but it's generally somewhere between 2 and 5 megabytes. And so there's a fairly limited amount you can do with that. So local storage is really great for like application settings, like developer preferences, stuff that you may be used to storing cookies, but not so great for like, oh, this is the data for my application. These are all my photos. Like, don't store photos in local storage. And so what do you do if you need to store more data? There's a dramatic pause. I mentioned mostly for completeness, there was Web SQL, which was introduced in Safari. It is what it looks like. It was, and it is SQL inside the browser. Whether you love or hate that, it was fairly familiar for a bunch of developers. However, it never got supported in Internet Explorer or Firefox. They both were against it for quite a few reasons, mostly the independent implementations. So it's never been supported in IE or Firefox. And even the implementations that do exist today, which Chrome, Opera, and Safari, they have, specifically for the reason Firefox didn't want to implement it, they have wildly varying bugs on different platforms because all they do is expose SQLite, and they have a whole bunch of different implementation issues. And it's really hard to build an application that works on one that you're guaranteed to work on another. So in general, like I mentioned Web SQL first because I hope you forget about it first. The only thing you need to remember is that if you're using it, you should have a really good reason. Like we needed to for PouchDB, but directly as an application developer, you should almost never be touching it. And so if you can't use Web SQL, what can you use? The main replacement came out as IndexedDB. I'm not going to go through every line of code here, but the thing to remember is this code snippet is exactly the same as the one-line local storage code snippet that I did a couple of slides ago. Like, some of the complexity isn't accidental. Some of it is thinking about very specifically the problems of building offline databases where you can't do like schema upgrades at the same time. That's why it's called on upgrade needed. But at the same time, it's a hugely complicated API. And it's got mostly good support. Firefox implemented it for a long time. Chrome have implemented it for quite a few versions on, obviously, Opera when they made the switch. Safari, however, Internet Explorer has been fairly good about this. It was later than Chrome, but it's in there, and it's reasonably stable now. There's still a few bugs to fix. Safari, as pretty much with most of the web standards, is the last to implement it. They did implement it in the last release, but it is buggy to almost unusable. So if you're looking to use IndexedDB directly, you're probably going to have to wait for a while, deal with a lot of Safari bugs, or you probably don't want to use IndexedDB directly. Instead, they're like similar to the whole jQuery movement. There are a whole bunch of people who build libraries on top of IndexedDB Web SQL, and they deal with the browser bugs for you. So a popular one is local forage. That is basically an asynchronous version of local storage. So if you just need to do key value store, then it doesn't have any of the performance characteristics of local storage. It's an asynchronous API. It doesn't block anything. So you can store photos in there. You can store blobs in there. It's all nice. db.js and YDN, they provide like really fancy querying ability. They provide just a nice, general, easier to use API on top of these storage. Because IndexedDB was kind of funny, as it was the first web standard that wasn't really designed to be used by web developers. It was kind of designed for libraries to be written on top of it. People wanted like Web SQL to be implemented on top of IndexedDB. And so that is getting close to what db.js and YDN do. And I think there are implementations of SQLite compiled in EM scripting to use IndexedDB. It gets weird. Another popular version, especially in Node development land, is level down. This gives an abstract API to the level DB API, which weirdly enough is what is used to implement IndexedDB. But there's polyfills for that level API that will work on top of IndexedDB, so you can write your application that uses level up. It uses all the nice streaming interfaces. It's a bit lower level. It doesn't have like transactional support, but it has like really nice streaming capabilities. And so if you're already using Browserify in Node, then this is a great option. Sweet. So now you can store stuff in the browser, and now you're finished building an offline-capable web application. It's not really. There's like being able to store stuff is just one part of a fairly large story, and there are a lot of things that come into building offline web applications. And so preloading content. Like when you go on the tube in the morning, you want to read all your emails that have been coming through that night. You may not want to, but some people do. And so it's useful to have applications that preload data that you might want to read in future. Filtered and selective sync, this is fairly common. So say Spotify, that has the world's music collection. It's fairly big, and you can't store it on every single device. So you need an ability to say, I want to grab this playlist right now, or I'm no longer listening to this playlist to free up some space. So when you're thinking about building applications that sync, you want to think about how to do filtered or selective sync as well. Updates and deltas, these are some of the more important ones, especially in implementation-wise. I'm building a Bugzilla client right now, and they might have thousands of bugs stored in their application data. You need to know when that's changed. And I can't sit there and pull Bugzilla for the whole content of thousands of bugs. That would take up huge amounts of traffic. You want to be able to say, I want everything that has changed since this point, and usually only the stuff that's changed. So when you're building sync applications, you need to think about notifications and being able to do delta changes and delta queries. And conflict resolution. So when you start being able to edit stuff offline, being able to use your application when the user isn't connected to a server, then you start getting into situations where people can make changes on different devices to the same data, and what happens when they come back together again. And so that's when you want conflict resolution. You can say the last update wins, but that means you've lost data. And for a lot of applications, that's perfectly okay. You can just say the last person to update this gets to win. But in some applications, say for Dropbox, where you're editing a photo onto different files, they want to make sure that you haven't lost your user's data. And so a lot of sync APIs in Dropbox will take into consider conflict resolution and store different versions of the data for you to be able to either roll back to or merge together. And so if you're building like an email client, then you're sorted. Like there's POP, that's old, you probably don't need to care about that. There's IMAP, that's already an open protocol. If you're building an email client, you kind of have to support IMAP. And that handles the protocol of being able to do sync. It does server-side querying, and even has unread and read status notifications built into it. So that is an open protocol that people have been building over a while. And if you're building an email client, you have to use that. Calendars, they have a similar thing with CalDAV. It requires a bit more work on your end. So some of the previous features you might need to think about a bit more as well. But again, it's an existing protocol that you'll probably have to live with. For your application, as long as it isn't an email or a calendar or some other contacts has its own protocol, at that point you're going to want to start looking at generic open source libraries that do this type of functionality and do this syncing for you. And so there's a bunch around. If you're using some of the popular JavaScript libraries around, so Ember has an Ember sync module for its data stuff, so you can almost just enable that and plug it into a server and it should be ready to go. JSGit sounds as crazy as it is, or is as crazy as it sounds. It's an implementation of Git inside JavaScript, and if you're building something like Atoms or Bracket or a code editor that needs to interact with Git, then that's absolutely amazing. It uses the full benefits of distributed Git, so you can have a version in your browser, and then you can commit that to GitHub when you want to go. There's also a really interesting project, Mozilla Make Drive, for the WebMaker project, which is a distributed file system, and they provide a file system API inside the browser, and that will do automatic syncs up and down and provide file system access on the server. So if you're building an open source Dropbox client, something like that would be amazing. And lastly, the project that I work on in my spare time that actually I didn't create. Michael over there started it about 3 years ago and then got sick of me making pull requests. This is another one of those libraries that provides fairly generic sync functionality to web applications. And it's written as a JavaScript library. It works in the browser. Similarly to the ones before that I talked about, it works over local storage, WebSQL, IndexedDB, so you don't need to care about those type of things. And so I'm going to do examples for PouchDB because that is the one that I work on and the one that I know. These work quite similarly across Make Drive or Ember Sync. They work in a similar way. They provide an API that lets you access and modify data. So that is what creating a database and putting stuff in it and querying looks like in PouchDB. Then on top of that, they add the ability to sync to a remote server. And so you can just say .sync, give it an endpoint URL, and as long, in this case, as it implements the CouchDB protocol, then all that data will transparently sync up and down. And Ember Sync and Make Drive do very similar type of functionality. And I'll do a quick demo. I'll do 2 quick demos. And so, this is an online version. This is CouchDB running on a server. This is its administrative UI. You can see there's nothing in this database. And as I mentioned earlier, the easiest way to go offline is to just kill the server. So now we have 2 different versions of my application, both running in they're separate browsers, so they're not the same instance. These could be easily be different devices. And so these work offline, and you can do a talk, and you can work on the other browser, and your application still functions offline. People are still able to interact with it. And then some of the nice parts about these sync libraries is you turn the server up, and then suddenly this is now in constant communication with the server. So now anything you do in one place will turn up in the other. So yeah, I can't even spell finish. Demo. And it will update there. You can edit this and anything. So it allows you to, by only dealing with the local instance of your data, you can just tell it to sync via a server, and suddenly you get an application that updates in real time across several places and works offline. And the other quick demo I wanted to do is just to say this isn't some weird framework that only I use. Is there's a fairly popular tool that a lot of JavaScript developers will probably be using. Is npm. It actually is using CouchDB to store its data. And so almost one day by accident, we're like, what is a cool demo for storing stuff locally? This was before in the time when npm had a lot of it used to crash a lot. And so we were like, oh, well, we can actually just use PouchDB because it implements the same protocol. And so if you go to this website now, it will download the entire npm inside your browser. Yeah, probably don't do it over this Wi-Fi if you're on a data network that's your own. But yeah, this completely, as I've got my Wi-Fi off, and I can access the whole of npm in my browser, and I can set up merge servers. It doesn't need to be in the browser, but that's kind of cool too. And so that was to talk about what already exists. These are the kind of tools you can use. They are fairly well supported across various browsers and implementations. But there's also, I just wanted to quickly mention, because I didn't have enough time to do a full talk about it, is the future. Due to a lot of the problems with appcache, Mozilla and Google have been working fairly heavily on a new proposal which is called service workers. It is just starting to land in browsers now, so it's behind a pref in Firefox Nightly, and I think some of the stuff is just starting to hit Chrome Canary. And this really excites me because the way that it's set up, it provides a possibility for people to be building web applications that are offline by default. So instead of having to do this extra work to cater for an offline mode, it could be hopefully in a future where we just build web applications that work offline by default. And so that is my talk. Tack.